This is going to be topic 11, additional problem solutions, part 2. Here we're going to be answering questions about supply and demand equations. The first set of questions tells us that, this is starting with question 4, that the demand equation where x, for the demand equation where x represents the quantity demanded in units of 1,000, in units of thousands, and P is the unit price in dollars, to sketch the demand curve, and B, determine the quantity demanded when the unit price is set to P dollars. So for number 4, we're told P is equal to negative x squared plus 36. Okay, so first thing we're asked to do is sketch the demand curve. All right, so let's go ahead and we see that this is a negative A, so this is an A of negative 1, so that's negative. So negative frown opens down. There's implied plus 0x here, and then there's the plus 36. So from that we get that a B equals 0 and C equals 36. All right, so if we want to figure out how to graph this, we're going to start out by finding the parabola vertex. So that's negative B, or negative 0 over 2A, and that's just 0. So we have a vertex at 0, and then the height of that is going to be given by, or the P, right? So I am going to look at what we call this function, and it's the height, and it's going to be, because this is actually a price per unit, when we substitute in 0. So another way to kind of formally think about it is we're thinking about this when x equals 0. And so that is equal to negative 0 squared plus 36 is just 36. Okay, the next thing we're going to need to do to sketch this this demand equation is we're going to need to figure out the x-intercept, and the y-intercept we got for free because the vertex is at an x-coordinate of 0. So this is not only the vertex, but it's also the y-intercept. And so if we're going to think about finding the x-intercepts, we need to set minus x squared plus 36 equal to 0. Okay, and we can just rewrite this as 36 minus x squared is equal to 0. So this is very similar to the problem number 3 that we just got done doing, because these are both perfect squares. So we can think of this as 6 squared minus x squared, and set that equal to 0, and by our rule that a squared minus b squared can be factored into a plus b and a minus b, we're able to go ahead and factor this as 6 minus x times 6 plus x. All right, I'm just following this rule. And I want to set that equal to 0. So when two things are multiplied together, right, we know we've been doing this a lot, one or the other has to be 0. So either 6 minus x has to be 0 or 6 plus x has to be 0. And we can solve each one of these, and we get that this is telling us that x equals 6, or that x would equal negative 6. The problem is, we know when we're talking about supply and demand that x, the domain, is that x has to be greater than or equal to 0. Okay, we cannot have quantities that are negative when we're doing business functions. So that means we are automatically going to eliminate this as a possible x-intercept. So let us now put together what we know of our sketch of our demand curve. We know that the demand curve has a y-intercept at 36. So we're going to go to x equals 0 and a price of 36. We know that it's opening down, and we know that it has an x-intercept at 6. So let's go 2, 3, let's go, sorry, 2, 4, 6. And I'll go ahead and put it in green. We know our price cannot go below 0. So this is going to be, the left side of this parabola is not included in our domain, so we can put it in with dots if we want. And we know that we can't have a negative price per unit when we're talking about a demand equation where we're setting the price per unit, unless we plan to pay people to take it off our hands. In some scenarios that could happen, but that's not what we're asked to do here. Okay, so now we're asked to determine the quantity demanded when our unit price is set to $11. So we're going to basically, let me see if I can make this a little bigger. The idea is we're going to come in where this is 11, and we're going to figure out what is the price when this is 11. I think I need a smaller pen. When our price is 11, remember the y-axis, when we don't talk about demand, is in dollars, and it's the price. So we want to know the price, when the price is equal to 11, what is X? That's what they mean by wanting to know the quantity demanded when the unit price is set to 11. So in order to do that, we are simply going to solve for X. So going back to our equations, make this a little smaller. We're going to go back up here to our equation for the demand, and we're going to solve that for X when we put in P equals 11. So this is going to be, let's see, I'll just write it over here. 11 is equal to negative x squared plus 36. Okay, so if we add 11 to both, if we add x squared to both sides, we'll end up with x squared. And if we subtract 36, we'll have minus 36 plus 11 is going to be minus 25 is equal to 0. And if we want to solve x squared minus 25 equal to 0, we get that that's x minus 5 times x plus 5 equals 0, or x equals 5, or x equals negative 5. But remember, we can't have x be negative. It's not in our domain. Right? Our domain is that x is greater than or equal to 0. So the only possible answer is x equals 5. So when our price is $11, our quantity is going to be 5. That's demanded. And that's the end of problem 4. Okay, now we're going to be asked to do the exact same thing in problem 5. So here, the price is set by this demand equation is negative x squared plus 16. All right, and we want to know the quantity when the price is $7. Okay, so the first thing we're going to need to do is graph this. And once again, we have the same situation. We have a negative 1x squared plus a 0x plus a 16. Okay, so our A is negative 1. Our B is a 0, and our C is the 16. Okay, so to find the vertex, we're going to set this to negative B, which is negative 0, over 2 times negative 1, which is all just 0. Okay, and if we want to know our price at 0, we're going to just put in XV. So price at the vertex is going to be minus 0 squared plus 16. Minus 0 squared is just 0, so this is just going to be 16. Okay. Now we might want to get, since this is the x equals 0, this is not only is it the vertex, but it's also the y-intercept. So now we want to find the x-intercepts. And to do that, we're going to set y, but here, remember, y, this is like, remember that this is the output. This is the output. And the output of a function is the same thing as the height. All right, so this is like the y. Okay, y is equal to 0, or in our case, p is equal to 0. So we want to go back over here, and we're going to set this function equal to 0 for p and solve for x. So 0 equals negative x squared plus 16. We can add x squared to both sides. Sorry. We can okay, so one thing we can do is we can factor out a negative 1. So if we factor out a negative 1, we get negative x squared minus 16. All right, so if you notice, this has got the same form as the last problem. It's an a squared minus b squared problem. So we could say it's minus, and this minus actually doesn't matter because it's just minus 1. And then we have x minus 4 times x plus 4. Okay, negative 1 can never be 0, so the only factors we have to worry about that could cause this to be 0 are x minus 4 and x plus 4. So x minus 4 equals 0 tells us x equals 4 is one of the x-intercepts, and x plus 4 equals 0. The second factor tells us that x has to equal negative 4, but that's not in our domain. So we're not going to consider that because the domain of any demand function or any supply function is x greater than or equal to 0. So that doesn't always get written, but it's understood that for business functions involving supply and demand, we only care about quantities that are positive. Okay. So now that we've gotten this far, we can now sketch our graph. It's going to be, remember, in that first quadrant only, and it's going to start out, for us, we're going to have a y-intercept, which we know is in dollars and represents the price per unit, which in class we also refer to as demand, the unit price given by the demand at x. So we know we have a y-intercept at 16. Let me go ahead and put a little blue dot there. And we know that we have a x-intercept at 4, right? So maybe we can do that one in green. So let's come over to 4. So let's say that that's 4. And this is our y-intercept, but we can't go below it because we can't have a price that's negative. So we're just going to connect these dots right here with part of a parabola coming down. And the other side of the parabola is not included. All right, so now that we did that, we want to find out what's the quantity when x is equal to 7. So we're going to go from a 7 over to our function and then read down what the quantity is. So maybe if I made that bigger, it'd be more clear. So if we started at 7, we go to our function, we hit the curve, and when we're going to read down, what is this? This is what we want to know. This is a question mark. And this is a 7. So let's go back to our problem. And here we have that 7 equals negative x squared plus 16. So if I add 7, if I add x squared to both sides and subtract 16. And what I end up with is x squared minus 9 equals 0. And I have that difference of squares again, so this is x plus 3 times x minus 3 is equal to 0. And the way that can happen would be only if x plus 3 is equal to 0 or x equals negative 3. But that's not in our domain, remember? So this is not an answer, so we have to go only with the ones that are positive. So when x minus 3 is 0, we add 3 to both sides, and we end up with x equals 3. So in answer to our question, our quantity in thousands of units, so if the price is $7 per unit, the demand is 3,000 units. All right, so we're going to use this 3,000 units. So the next question is one regarding the supply equation. And this question is number 6. It's going to be very similar, but the supply equations are always increasing functions, whereas the past 2 demand equations had parabolas opening down. Now that we're talking about supply, we'll be talking about parabolas opening up. So the supply equation is where the x is also here going to be supplied in units of thousands. And remember, P is going to be our unit price. So the function we're given is that P is equal to x squared plus 16x plus 40. All right, so once again, we are able to see on here that we have a 1 times x squared plus 16x plus 40. And it is this 1 that's positive, right? So 1 is positive. It's the coefficient in front of the x squared term. So the A equals 1 is positive or smiling, right? So let's go ahead and find out some more information about this function. So let's start out by finding that vertex. The vertex value is going to be negative b over 2a. So in this case, it's negative 16 over 2 times 1, or just negative 8. So when x is equal to a negative 8, we're going to have our vertex of this parabola that's opening up. And what's the height at that point, or the yv, which I can call pv, right? Would be where the vertex is. And it's given by negative 8 quantity squared. I'm now looking at the original function. I'm going to substitute my vertex value in. So I have negative 8 quantity squared plus 16 times negative 8 plus 40. All right, so this is going to be 64. And 16 times negative 8, I need a calculator for. I could do it on paper, but I just want to get it done quickly. So let's see. That's 16 times 8 equals 128, and there's a negative, so I got to say minus 128 plus 40. Okay. So if we put that in our calculator, so we're going to get 64 plus 40 minus 128 gives me a negative 24. All right, so we already knew that this x was not in our domain, but because we're trying to sketch this supply curve, it's still helpful for information for us. So the next thing we want to do is figure out where the x and y intercepts are. So let's talk about the y-intercept. So the y-intercept, we call it the y-intercept, but remember that it's really like the p-intercept because that's what's on the y-axis, is when x is equal to 0. So for us, the unit price when x is equal to 0, right? So this is the price when when there's no quantities that the lowest price before anybody is willing to sell this product. So we'll see that what that means more in a second. But again, I'm just going to put in to the equation x equals 0. So we have 0 squared plus 16 times 0, right? All this is just 0 plus 40. All right, so that tells us that at 40, it's going to, we're going to have a price per unit of 40 at the y-intercept, or when x equals 0. And then we can look at what happens when the p is equal to 0. This is finding the x-intercepts, or x-intercepts, singular. So going back to our function, we want to know when x squared plus 16x plus 40 is equal to 0. Okay, let's try seeing if we can factor this. So 4 times 10 is going to give me 40, but that will not add up to 16. 5 times 8 is 40, but that does not add up to 16 either. 2 times 20 could give me 16. Could give me 40, but that can't give me 16 either. So, I don't think this is factorable. So let's go ahead and use a quadratic formula. So x is equal to negative b plus or minus the square root of 16 squared minus 4 times 1, a is 1, right? We already determined that, times c, which is 40. All over 2 times 1. So let's work on that. We have negative 16 plus or minus, and here we need to do what's underneath the radical sign. So what we're going to do is we're going to get 16 squared. And we're going to subtract from that 4 times 40. And what we end up with is 96. Just want to confirm that. Okay. And that whole thing's over 2. All right, so now we can go ahead and put this in our calculator straight away if we want to try to figure out this value. So if we put in the square root of 96, it's not, it's going to be a number that is a fraction. So I get that this is coming out to be minus 16 plus or minus 9.8 all over 2. So x is equal to negative 16 plus 9.8 divided by 2. All right, so if we go in here, we can say that this is going to be 16 negative plus 9.8 divided by 2 is that this is equal to negative 3.1. And then the other value is going to be negative 16 minus 9.8, the whole thing divided by 2. It's minus 8.5. Okay. So we have now enough information that we can graph this because we have the we have the vertex at minus 8 and minus 24, so that's the ordered pair minus 8, minus 24. We have the intercept at minus 3.1 and minus 8.5. So let's go ahead and graph this. All right, so let's go to minus 8, minus 24. So let's go minus 2, 4, 6, 8. Let's say that's minus 8. And we're going to go over here to minus 24. So let's count by tens. Minus 10, minus 20, minus 30. So at minus 8 and minus 24, which we're going to say, let me go that in blue. We're going to say that is approximately where the vertex is of this function. Now we're going to just pick a point to the right of this, which is minus 3.1. So this is 3.1, and this is the x-intercept. We're going to be somewhere right around in here. Okay? Now, our function, I guess I'll go with green, cannot, this is a vertex here, but we're not allowed, our domain specifically says that x has to be greater than or equal to 0. So we're going to just continue this parabola until we cross the x-axis. Sorry, cross the y-axis, which happens at, we also figured that out, didn't we? This is at 40. So right here, this is 40. And I have to go back to the question to see, yes, this is the unit price. It's in dollars. And then we want to know to determine the price at which the supplier will make 2,000 units available on the market. So we want to know what price will make 2,000 units available on the market. So let's go over here, and we have x squared plus 16 plus 40. 16x plus 40. And what we want to know is what is the price per unit if we're willing to make 2,000 units. So the price when x equals 2,000. See what I did? I just wrote this again, but focusing on that it's a function. So I can have an input, and then I'm going to calculate that. So it's 2,000 squared plus 16 times 2,000 plus 40. Okay, so we put that in our calculator. We get 2,000 squared plus 16 times 2,000 plus 40. So I made a mistake. If I went back and read this, it said the supply equation is given in units of thousands. So this should not have been in as 2,000. X should only equal 2 because it's in units of thousands, right? And 2 is 2 times 1,000. All right, so this is not accurate. Let's go back and do this right. We're going to do this for x equals 2, which is what corresponds to 2,000 units. So now we'll get 2 squared plus 16 times 2 plus 40. All right, so now we get 4 plus 32 plus 40, and we're going to end up with 72 plus 4 is 76. So the price that that the supplier wants to sell these units is when there's 2,000 units available on the market is $76 per unit. All right, so that's from the supply curve, and that tells us how much the supplier wants to sell the units at for that many.